So now that we've set up our system using Kickstart, or a hands-free based installation, minus specifying the ks.cfg file at the opening screen, let's show you how to set up a Kickstart or kick off a Kickstart installation that will also create a RAID device for the root file system, as well as set up higher resolution and colors. So let's open a shell and launch system config Kickstart. We'll open the recently created Anaconda Kickstart configuration file and make changes to it. So here's a file which contains most of the settings that we're interested in. Installation method is set with the appropriate URL. Let's set a grub password to protect the bootloader. It'll be encrypted. Partition information is currently not set, so we'll define some partitions and set up RAID. We'll clear the boot record, remove all existing partitions, and initialize the disk label. Then we'll add a boot mount point which will not be RAIDed. It'll be ext3, 100 megabytes, set on a specific disk, SDA. We'll create a RAID software partition, or software RAID, setting it to 10 gigabytes. We're going to create a RAID5 partition for the root file system. This partition will also be on SDA, the first hard drive, and we'll duplicate this partition on the other disks. So let's create another software, two more software RAID partitions, one on SDB and the other on SDC. All will be 10 gigabytes each. So this will be on SDB, and the last on SDC. So now we have three software RAID partitions, just enough to create a RAID5 device. Let's click on RAID, and now we have the ability to create the first RAID device located beneath the dev tree as MD0. Here are the disks that can be members. The default RAID level is 0, so we'll set it to 5. The supported types include 0, 1, and 5 for the disks presented, and for Kickstart. The file system will have journaling, so we'll change it from ext2 to ext3. The default device, MD0, as opposed to any of the other MDs. No spare devices exist at this point. We'll format the RAID device, and the mount partition will be root. So this will create our RAID entry, MD0, for the root file system. Now let's go ahead and define some other partitions. We should have a swap partition. We'll set it to 1024 megabytes. And we'll place the swap partition on SDB, the second hard drive. So now we have what we need: a boot partition, a root partition that will be created on a RAID5 device known as MD0, which will be about 20 gigabytes free and will contain all of the other mount points, including var, and a swap partition on SDB, which is roughly twice random access memory. Beneath network configuration, ETH0 is configured, authentication is local, shadow and MD5, firewall defaults to enable SE Linux is enabled or active, SSH is permitted. Let's increase the color depth to 16 for the video card, and the resolution to 800 by 600, so it's a little bit clearer. None over 5 will be the default. Package selection will default to whatever is in the Anaconda Kickstart file, and then we'll go ahead and save the file as ks.cfg. Then we will copy the file to the remote server. That's scp ks.cfg as root to the web server. Beneath its serve www.linuxcbt.com directory, we need a colon here as a demarc. This will prompt us for authentication, and if we briefly peruse ks.cfg, we'll see the entries, in particular the partitioning setup, which includes the RAID partitions and the normal partitions. So this is fine. This will set up a RAID partition, give us the higher resolution, higher colors, and we'll be off to the races. So with that said, we should now reboot the PowerEdge server, not this system here, the PowerEdge system. This happens to be another Red Hat Enterprise Linux system. And once it's rebooted with the boot ISO CD image, we'll be able to reference the Kickstart configuration file. So that's what we'll do at this stage. So now we're rebooting our box. It'll be up to the Start menu momentarily. We'll specify Kickstart configuration and let it rip just like we did previously. Again, Kickstart's pretty straightforward. There are some limitations with respect to packages and LVM creation during installation, but other than that, it works pretty well and allows you to deploy multiple systems rather quickly. So we'll just get through our hard drive detection phase here. And we'll have the boot menu momentarily. So now we're at the main menu. Again, we'll indicate Linux, KS, and the path to the Kickstart configuration file. And that's located at .100/ks.cfg. Driver detection is occurring and compatible drivers are being loaded for different types of storage subsystems. We've connected to the HTTP server. X configuration. And here we're retreating installation. We've been propelled into GUI mode. So we're moving forward just like we did with the last installation. Now if there are any errors or problems or issues with the way we've laid out the RAID partition or any of the partitions, we'll be notified by the installer. In other words, we'll be prompted for intervention. But barring no problems with the Kickstart file, this installation should flow seamlessly, just like the last Kickstart installation. Just like before, the dependencies have to be checked. That's always going to take place to be sure that programs will not be in a broken state. And again, expect during installation, especially across the wire, for some of the packages to pop up or some of them to not install the first time around, forcing you to have to specify or click on retry to have the installation process try the copy process again. So sometimes the copy steps fail, especially in a network session or in a situation where your network is congested, and sometimes with dirty local media. Here's the GUI. Various file systems will be formatted, including root and the RAID file systems, or the RAID partitions, that is, which ultimately get overlaid with ext3 file systems. But the designation of software RAID means something special to the kernel, that the partitions work in concert as opposed to independently. And we're almost ready for the copy step, which handles the transfer of the hundreds of RPM packages from the distribution point, which is the HTTP Apache server, to the local system. Again, there are other ways to install Red Hat Enterprise Linux, including from an RPM repository located on a local hard drive connected to the system. Here we've already got an error with one of the packages. We'll just click on retry, and this will move the process forward. But the key steps are out of the way. Setting of the resolution for when the system starts and run level 5, and the layout of the partitions, which you can confirm by accessing the other consoles using Control-Alt F1 through F5. And now we're copying files, beginning with GCC, or the GNU C compiler. As you can see, packages are being copied effortlessly. Again, we've seen time and time again, especially with a network installation, the copy process fail on the first try, but succeed on the second. So just be prepared to click on retry a couple times during installation across the wire, especially in busy network settings. And we're approaching the halfway mark. And we're just over the halfway point with about 10 minutes to go, so we should be wrapping up this automated installation shortly. Again, this is a Kickstart-based installation with a RAID partition. We'll wrap up by confirming, we'll propel into single user mode and confirm that the root file system is indeed on a RAID device, MD0. We're just about wrapping up here, down to 4 minutes, just under. So this is wrapping up, performing post-installation configuration, which is the installation of Grub, and we'll reboot, then launch into single user mode and confirm that the RAID device has been created. So let's move forward with rebooting. We'll be up momentarily. Let's ensure that the CD-ROM isn't in the drive so it doesn't boot the installation program, but rather boot from the hard drive, and we'll interrupt the Grub boot process by indicating single user mode, or the keyword single, by appending it to the kernel boot line. And here's the boot menu. To make changes, we have to insert the password, then press E to edit, then navigate to the kernel boot line and edit it using E by appending single. All of the options on the command line are processed by the Linux kernel. Enter to return to the main menu, and then B to boot, which will propel us into single user mode. Now we'll launch into single user mode. So it's df-h. In fact, above you can see devmd0, and it came up clean. This means the root file system is available. So df-h will reveal as such, and there it is. Root is bound to a RAID5 device, which is accessible in the dev tree via devmd0. The boot partition is an independent partition that isn't RAIDed, and then of course there's a swap partition, which we can reveal with swap on S, which is on the second hard drive. So we have a new installation that was created with Kickstart. The Kickstart configuration file anaconda- ks.cfg is available in root's home directory. Let's navigate into root, less the contents of Anaconda, and there it is. And in it, you'll see that the partition information is commented out. So when we subsequently re-import this config file into the Kickstart configurator, it won't process any partition information, so we'll have to uncomment these settings for it to take effect. And again, that's with good reason. In the event that you intend to reinstall subsequent systems that aren't identical to this system disk-wise using this Kickstart configuration file. So with that said, our system's up and running. We'll emit 0 to shut the system and then move on.